Hello, dear space explorers. QUASARIA channel is with you again, and we're continuing our exciting journey through the types of galaxies. In the last episode, we talked about spiral galaxies, dynamic, life-filled structures where new stars are born every day. We studied our home Milky Way with its majestic spiral arms and active stellar nurseries. But today we're heading to a completely different world. A world of silence and calm. A world where time seems to have stopped billions of years ago. We'll talk about elliptical galaxies, giant cosmic cemeteries that astronomers have dubbed zombie galaxies. Why zombies? Because these galaxies are dead in the sense that virtually no new stars are born in them. They consist of trillions of old, slowly dying luminaries. But they continue to exist, dominating galaxy clusters and absorbing their smaller neighbors. Today we'll learn how these cosmic monsters form, why they have no gas for star formation, and what fate awaits our own Milky Way. Ready to look into the face of cosmic death? Then let's go. Let's start with the basics. We're elliptical galaxies. Unlike flat, twisted spiral galaxies, elliptical galaxies have the shape of an ellipsoid, a three-dimensional elongated sphere. They can be almost perfectly circular or highly elongated, like a football. The most important difference from spiral galaxies is the absence of a clear structure. They have no disk, no spiral arms, no active star-forming regions. Stars in elliptical galaxies move chaotically in random directions, forming a diffuse cloud. Elliptical galaxies are classified by their shape from E0, nearly spherical, to E7, highly elongated. The higher the number, the more elongated the galaxy. The sizes of elliptical galaxies vary enormously. Dwarf elliptical galaxies may contain only a few million stars and have a diameter of several thousand light years. And giant elliptical galaxies are true monsters, containing tens of trillions of stars and stretching for millions of light years. The color of elliptical galaxies is usually yellowish red. This is because they consist predominantly of old stars. Young blue stars that adorn spiral galaxies are virtually absent here. The term zombie galaxy may seem dramatic, but it accurately reflects the nature of these objects. In a typical elliptical galaxy, the star formation rate is close to zero. In some cases, one new star may be born once every 1,000 years or less. For comparison, in our Milky Way, 1 to 2 new stars are born every year. Why does this happen? It's all about the absence of cold gas, the main raw material for producing stars. Elliptical galaxies have virtually no molecular hydrogen clouds from which stars form. All the gas was either consumed billions of years ago or heated to such temperatures that it cannot condense into stars. Imagine a city where children are no longer born. The population consists only of elderly people who are slowly aging. No new buildings are constructed. Infrastructure is deteriorating. The city continues to exist, but there's no life, movement, or development in it. The same goes for elliptical galaxies. The stars that are there slowly evolve and die. The most massive stars long ago exploded as supernovae. Only low and medium mass stars remain, red and yellow dwarfs, which will shine for billions more years, but their light is dim and cold. However, elliptical galaxies are not completely dead. At their centers are usually supermassive black holes, which can be very active, absorbing matter and emitting powerful radiation. But this is not star formation. This is agony, the last convulsions of a dying system. The origin of elliptical galaxies is one of the most interesting mysteries in astronomy. And the answer to this mystery is connected with cosmic catastrophes of unimaginable scale, galaxy collisions. There are two main scenarios for the formation of elliptical galaxies. When two spiral galaxies approach each other, their gravitational attraction becomes stronger and stronger. A cosmic dance begins that can last hundreds of millions or even billions of years. The galaxies pass through each other. Remember that stars are at enormous distances from each other, so direct star collisions are extremely rare. But gravitational interaction destroys ordered structures, spiral arms, disks. Gas clouds collide and compress, causing a powerful burst of star formation, the so-called starburst. In a few tens of millions of years, as many stars can be born as are usually born in a billion years. But this celebration of life is short-lived. Young massive stars burn out quickly and explode. Their explosions heat the remaining gas to millions of degrees. Hot gas cannot condense into new stars and is ejected into intergalactic space by powerful winds. Eventually, the two galaxies merge into one. But this is no longer a spiral galaxy. Due to the chaotic movement of stars during the merger, an elliptical galaxy forms, a giant cloud of old stars without any ordered structure. Large elliptical galaxies can grow by absorbing smaller neighbors. Dwarf galaxies passing too close are torn apart by tidal forces. Their stars scatter and become part of the larger galaxy. This process is called galactic cannibalism. It's especially common in the centers of galaxy clusters, where giant elliptical galaxies dominate, gradually devouring everything around them. Although elliptical galaxies seem simple and homogeneous, they have their own internal structure. The nucleus, the central region with maximum stellar density. At the center is a supermassive black hole whose mass can reach billions of solar masses. The more massive the galaxy, the more massive its central black hole. The main body. This is where most of the galaxy's stars are located. Stellar density gradually decreases from the center to the edges. Stars move in complex, intersecting orbits. The halo, the outer region, which can extend over vast distances. The halo contains globular star clusters, dense groups of hundreds of thousands or millions of old stars, as well as a huge amount of dark matter. Interesting feature. Many elliptical galaxies rotate very slowly or don't rotate at all. Instead of ordered rotation, as in spiral galaxies, stars move chaotically. Some move in one direction, others in the opposite. Also discovered in elliptical galaxies is a complex structure in the form of shells and stellar streams, traces of past absorptions of smaller galaxies. These structures are like scars, reminding of the galaxy's violent history. Although elliptical galaxies have no cold gas for star formation, they contain enormous amounts of hot gas. This gas has a temperature of millions of degrees and emits in the X-ray range. The mass of this gas can be comparable to the mass of all stars in the galaxy. Where does this gas come from? First, it's gas ejected by supernova explosions. When massive stars explode, they eject their envelope into space at tremendous speed. This material heats up to extreme temperatures. Second, old stars constantly lose mass through stellar wind. Over billions of years, this produces a significant amount of gas. Third, the galaxy can capture gas from the intergalactic medium, especially if it's located in a galaxy cluster. But why doesn't this gas cool down and form new stars? Several mechanisms are at work here. The supermassive black hole at the galaxy's center can eject powerful jets, streams of matter moving at nearly the speed of light. These jets heat the surrounding gas, preventing it from cooling. There's also a feedback process at work. If stars begin to form somewhere, supernova explosions quickly heat the gas and stop further star formation. A vicious circle results. No cold gas, no new stars, no gas cooling mechanism, no cold gas. The zombie galaxy is stuck in this state for billions of years. Not all elliptical galaxies are the same. Astronomers distinguish several subtypes. Dwarf elliptical galaxies, the smallest and most numerous. They contain from a few million to a billion stars. Diameter, several thousand light years. Often satellites of larger galaxies. For example, several dwarf elliptical galaxies orbit around our Milky Way. Normal elliptical galaxies, medium size and mass. They contain billions of stars. These are the galaxies formed by the merger of two Milky Way-sized spiral galaxies. Giant elliptical galaxies, true monsters. They contain tens of trillions of stars. Diameter can reach several million light years. These galaxies are usually found in the centers of large galaxy clusters and formed as a result of multiple mergers. CD galaxies, the largest galaxies in the universe. The name comes from a classification meaning central dominant. Mass can exceed the mass of the Milky Way by 1,000 times. These galaxies have an extensive diffuse halo that can span several million light years. There are also intermediate types, galaxies that have features of both spiral and elliptical galaxies. They're called lenticular or S0 galaxies. They have a disk like spiral galaxies, but no spiral arms or active star formation. Let's get acquainted with several impressive examples of elliptical galaxies. M87, Messier 87, a giant elliptical galaxy in the Virgo cluster, about 53 million light years away. Contains several trillion stars. Famous for its supermassive black hole with a mass of 6.5 billion solar masses. This is the first black hole that was directly photographed in 2019. A relativistic jet 5,000 light years long burst from M87. M87 is also surrounded by a huge swarm of 12,000 globular star clusters. For comparison, the Milky Way has only about 150 of them. Centaurus A, NGC 5128, the nearest active galaxy to us, located about 12 million light years away. This is an elliptical galaxy with an unusual dark dust lane crossing its center. It's believed to be the result of a recent, by cosmic standards, merger with a smaller spiral galaxy. M32, a dwarf elliptical galaxy, a satellite of the Andromeda galaxy, located 2.5 million light years away. Despite its small size, it has a very dense nucleus with a high concentration of old stars. IC 1101, one of the largest known galaxies in the universe. Diameter about 6 million light years, 60 times larger than the Milky Way. Contains about 100 trillion stars. Located in the center of a massive galaxy cluster more than 1 billion light years away from us. The fate of the Milky Way. Now it's time to answer the question that has probably occurred to many. What will happen to our Milky Way? Our galaxy has a date with destiny, and this meeting is inevitable. In 4 to 5 billion years, the Milky Way will collide with the Andromeda galaxy. What will happen? First, the two galaxies will approach, pass through each other, destroying spiral structures. A powerful burst of star formation will begin due to the collision of gas clouds. The sky of future Earth, if it still exists, will shine with thousands of young bright stars. But then the end will come. Gas will be consumed or ejected. The two galaxies will merge into one giant elliptical galaxy. Astronomers have already given it a name, Milkomeda or Milkdromeda. This new galaxy will contain 1 trillion stars, but star formation in it will virtually cease. It will become a zombie galaxy, huge, majestic, but dead. Our sun will probably survive this merger and be ejected into a distant orbit in the halo of the new galaxy. From there, from a distance of hundreds of thousands of light years, our distant descendants, if they exist, will be able to observe the bright elliptical core of Milkomeda. So the future of our galaxy is transformation into an elliptical galaxy. The life cycle will close. So, friends, today we immersed ourselves in the world of elliptical galaxies. Ancient giants where time stopped billions of years ago. We learned that these galaxies form as a result of cosmic catastrophes, mergers of spiral galaxies, that virtually no new stars are born in them, and that this is exactly the fate that awaits our home Milky Way. Elliptical galaxies show us the final stage of galactic evolution. Order turns into chaos. Life gives way to slow extinction. But even in this death, there is grandeur and beauty. In the next episode, I'll show you the complete opposite of ordered spirals and regular ellipses. We'll head into the world of irregular galaxies, cosmic chaos, galaxies without symmetry, without a clear shape, exploded, warped by gravitational interactions. Why are they so strange? How did they form? And what happens when two galaxies collide right now? Before our eyes? Get ready for the most dramatic views in the universe. Like, subscribe to the QUASARIA channel and turn on notifications. There are even more amazing discoveries ahead. See you in space.